Assalamu alaikum. My name is Fiza Agha, and the group members are Rusa Khan, and my roll number is 183, and we are from Section C. So, today the topic that is given to us is questions related to PMF, PDF, CDF with description. So, I'm just going to give you a short introduction about PMF, PDF, and CDF. So, basically, PMF stands for Probability Mass Function. PDF is stands for probability density function and CDF stands for cumulative distribution function. So the difference between all of them is that PMF is basically a probability that discrete random variable is exactly equal to some value. PDF is basically a density of a continuous random variable and CDF is basically a real valued random variable. So now I'm going to tell you that how probability distributed the functions. Basically, the probability distributed the functions in two types, that is a continuous and a discrete. The discrete function is basically PMF, that is probability mass function, and continuous is probability density function, that is PDF. The mixture of PMF and PDF is CDF, that is cumulative distributive function. Now further I'm going to discuss about that how can we cure the behavior of random variable. So as you can see that we took a dices here and it's a very common example that we can take. So we have lots of distribution in maths as well that we have to characterize the random variable. So for this one we are considering a six-sided dice that if we are gonna roll that there will be a random variable. Okay, so we characterize that random variable with uniform distribution. Like you can see that it is flat and it can indicate the outcomes equally, right? So now moving on to the next example that has given, that is a many dices. Like we took several dices together and it will be a random variable as well, of course, but it will characterize normally. Okay, this will characterize basically this will indicate the outcomes equally and this will indicate this will characterize normally. So now we have the third one, that is process background. So basically this is an operational process that backgrounds every that breaks down every one in a while that random intervals does, and random variable that we decided to characterize with the poise. So now, further I'm going to discuss more deeply about what is probability mass function. So I already told you that it is a discrete random variable which is exactly equal to some value. So now, PMF basically is a defines the discrete probability distribution. That means that it is either an scalar or a multivariate random variable whose domain is discrete. And the difference between probability mass function and probability density function PDF is that that is a letter which is associated with continuous rather than discrete random variable. A PDF must be integrated over an interval to yield a probability. So now I'm going to show you a graphical representation of PMF that you can easily understand. So you can see this graph that I can count from 1 to 10 so easily, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? But what if I'm gonna have five and a half? Can I have it? No, I cannot have a five and a half because this is a discrete random variable. And always remember, discrete random variable is individually separate yet distinct. So we can count it as a finite function, but because it is a discrete, so it will definitely be individually separated. And you can see this PMF is exact to Px equals to x. That means probability is equal to exactly 3 but not approximate. It is exact, right? So for further information, my friend Urusa Khan going to tell you about what is a PDF and CDF.
Assalamu alaikum. My name is Urusa Mashkur. My roll number is 116, and now I'm further discuss my presentation. So now first I'm discussing what probability density function is, which is called PDF. So in probability theory, the PDF or the probability density function is a function whose value at any given sample or any given point is same. Now I further represent what's PDF in graphical form. So first let's consider continuous versus discrete. So there is a plot, as you can see, this plot, this blue line, which shows normal distribution in this graph. This line basically indicates that it's a continuous distribution that characterize continuous variable. सो बेसिकली ये लाइन जो है ये इनफाइनाइट नंबर ऑफ पॉसिबिलिटीज़ को शो करता है पीडीएफ में. पीडीएफ requires an interval, two interval, so pdf shows the probability lies between these two intervals. So this continuous measured infinite method जो है वो gives the local probability of approx outcome of a random variable. Now I'm discussing what cumulative distribution function is. So basically, it's a probability theory statistics. The CDF is a real random value of x or xyz, what uh, alphabet you choose to represent your CDF. So here's a graphical representation of CDF. In this, there is a two graphical representation basically of CDF. First, we can do CDF and versus PDF and CDF versus PMF. There we can see a blue line in here at the bottom, which shows the normal distribution that that shows PDF probability, and this purple line, as you can see here, uh, this purple line characterize the area under the curve, and that's left therefore the probability of random variable and less than or equal to same number variable. That's where this purple line rise up. And the other end in CDF versus PDF, all is same, but this dotted line shows that it's a binomial distribution. So now we are discussing what's the difference between discrete and continuous. So the first difference is measurement. Continuous can be measured while the discrete functions are counted. There is an infinite number of outcome in continuous, but there is a finite number of outcome in discrete. So here's the three example of continuous, that is distance, time, asset return, and in discrete here is default. Default can be 1 or 0, default or not default, and the second is frequency of loss. So this is an example of continuous versus discrete. So this is the presentation we shared with you. Thank you so much.